Okay, so I also now want to start talking about how do you know a function has a horizontal asymptote? Okay, so the vertical asymptotes and holes came from when the denominator was 0, and so that was nice and easy to recognize. But for a horizontal asymptote, what you have to do is you have to look at and compare the highest power, the degree of both the numerator and the denominator. Okay, so for that, for these examples, we're looking for that, who has the higher power. So we want to look at highest degree. And when I'm talking about degree, I'm talking about what is the exponent of the highest polynomial, right? So look at the highest degree in the top and bottom, or in the numerator and denominator. And you need to compare those numbers. The idea is to see like who wins, who has the bigger number, okay? So if denominator has the bigger number, denominator has a higher degree than the numerator. In other words, the denominator wins. If the denominator has a higher degree than numerator, then the y equals 0 is the horizontal asymptote. And I'll abbreviate it HA, okay? So if the denominator has a higher degree than the numerator, y equals 0 would be a horizontal asymptote. Here's an example. Let's say you had f of x equaled x plus 3 over x squared plus 3x plus 1. So if I'm looking at the degree, I would notice that the numerator's degree is only 1, the denominator's degree is only 2, or is 2. This is bigger. So this would mean that y equals 0 is a horizontal asymptote. Now, if it has a horizontal asymptote, it says nothing if it does or does not have vertical asymptotes or holes. These are independent of each other. Okay, now, what if it doesn't? So, like, if the denominator has lower degree, in other words, the top wins. So then the numerator, then there isn't one. Then no horizontal asymptote. So as an example, I might say, okay, well, maybe we have g of x is equal to maybe x cubed plus 3x over 2x squared plus 1. Okay, notice the top has a highest degree of 3, the bottom has a highest degree of 2. Top wins, so there's no horizontal asymptote. But again, that doesn't say anything if there's a hole or a vertical asymptote. We're just focusing on the horizontal asymptotes. Okay, now, most likely there'll be a tie if degrees match. Or I shouldn't say most likely. I said sometimes they can, right? So if degrees match, then there is a horizontal asymptote, and the equation, the horizontal asymptote, then the horizontal asymptote has an equation equal to the ratio of the coefficients. The horizontal asymptote has an equation equal to the ratio of coefficients. And I'll show you what I mean by that with an example. So, as an example, what if we had, maybe h of x equals, let's say, 3x squared plus 5x plus 11 over, let's say, 2x squared plus 10. So I noticed that the highest degree is both squared and both. So it's a tie. So what I then look for is, well, what's the ratio of the coefficients of those lead terms? Oh, it's a 3-to-2 ratio. Awesome. Then that's my asymptote. So then I would say y equals 3 over 2 is the horizontal asymptote. So that only happens when there's a tie. So we can look at some examples here down below and notice we're just looking for horizontal asymptotes. Like, for example, I'm looking at A. I already know from the previous videos that, hey, look, there's x equals 1 as a vertical asymptote, but I'm more interested in the horizontal. So I'm going to look at the degree. And so in the degree, like there are 0 x's on the top and the x to the first power on the bottom. So the bottom wins. The denominator is a higher degree. So automatically y equals 0 is my horizontal asymptote. Okay, example B. They both are linear. So look at the ratio of the coefficients, 4x and x. So then, even though I already know like x equals 7 would have been a vertical asymptote, I also know that y equals 4 is the horizontal asymptote. Okay? Now, the next example here is they're both quadratic, right? X squared, it's a tie. So we look at the ratio of those coefficients. It's like a 1 to -1. So I would say it's horizontal asymptote is y equals -1. It's that ratio. Okay, so D is a little bit tricky because you have to do a little bit of math. Like if I were to have expanded this, my lead term would actually be 4x squared. And there's other things, but the lead term on the top is 3x squared. So again, that ratio, since it's both squared, they're both the same degree, that means that y equals 3/4 is the equation of my horizontal asymptote. Okay. And again, if you want to pause the video and try the next 4 on your own and then see how you do, awesome. If not, just follow along. Okay, so again, I'm looking at the highest degree. These are both quadratic. It's a 1 to 2 ratio. So I know my horizontal asymptote is y equals 1/2. Okay. Here, let's see, the highest degree is squared. Here is linear. The bottom wins. So y equals 0 would be my asymptote there. Again, G is a little bit of arithmetic. If you cube out 2, it's 8. And then times -3, so that's really -24. X to the 4th power would have been the lead term. Down here, 6x to the 4th power is the lead term. The x to the 4th powers would cancel, and so y equals -4 would be my horizontal asymptote. And the last one here, H, again, 1 to 1 ratio, so the asymptote is y equals -1. Okay, so the first things you should always try to find in your rational functions are exactly what we've seen videos on. X, if there are any holes, any vertical asymptotes, and any horizontal asymptotes. And you're going to find that the next thing we look at would be x-intercepts and y-intercepts. But, like those, those are things we've already knew how to do. These videos, again, I'm trying to focus on, well, what is it that is new in these rational functions?